Go wild. So that's how the episode starts, with Jillian
Oh,
saying,
no.
"Go wild."
That's not what
Speaking
I
of
was
which,
saying on the internet.
yeah, too late. It's
Too late
done.
now. It's okay.
Speaking of which, you are back on the show with us. You're back in the US. So what's been going on?
Well, I mean, I moved continent, so that was a pretty big thing. And now I'm in the US full time, which is exciting. I'm like just 2 hours north of Boston in a little town that probably nobody has ever heard of in New Hampshire. But it's been fun. It's been a big adjustment, but it's been a really good time.
Yeah, you were in Doha, right?
Doha, Qatar.
Doha, yeah.
Yeah, so it's in the Middle East.
So, yeah, Doha to New Hampshire.
Mm-hmm.
There's some adjustment there.
There is. There's a lot more color here. Like just in general, it's very
I'm sure, yeah. I've not been to Doha, but I have been to Dubai several times, and I think they're fairly similar. Yeah.
Yeah, it's like less than an hour's plane ride. They're about the same thing.
Yeah. Cool. So back in the US permanently, or is this a temporary thing for you?
Permanently. No, I'm living here now.
Right on. Well, cool. Well, welcome back home.
Thank you. It's been nice. I'm very happy to be back, and it's nice that professionally it's so much better for me too. I don't have to work split shifts, and that's great. And I get to be back on the podcast and talk to you guys, which is obviously the biggest win.
Of course, yeah.
Of course. Go harass my clients in Boston now. That's where most of them are at, and here we are.
Oh, but 2 hours, and so you said maybe no one knows about that, but I actually made that drive a fair number of times up to Lake Ossipee. So there's a whole bunch of town there that I could probably rattle off, and maybe you're living in one of those. That's a long drive to get from New Hampshire down to Boston.
I'm not driving though, so it doesn't bother me. I drive to the bus station, and then one of those very nice buses takes me into Boston. I'm not trying to drive in Boston. Like that's not a thing that we're doing. So it doesn't really matter.
Right, because you're on the East Coast where they actually have public transit.
Yeah. The bus is actually nice. Like I don't actually mind taking the bus. It has like the really nice big seats, and it goes right into South Station, and then I don't know, most of my clients are like 10, 15 minutes from there.
That's cool. I do kind of miss that. I miss that every once in a while, of just seeing and working with people face to face.
I do. I actually do like that. Like I wouldn't even really want to have a hybrid job, but showing up like, I don't know, quarterly and just going to go see everybody. Usually it's for some type of meetup. There's like, a big meeting of the minds happening, or a conference or a talk or something like that. And then I'll go.
For sure. So what was it like moving across continents? Did you bring couches and mattresses and furniture, and no?
No. It's all, I don't know. I guess like living overseas, all the furniture and stuff got treated as kind of disposable because there was enough of those moves. And the last place that we were at was mostly furnished anyways, so I didn't have a lot of furniture. So I bought furniture when I bought the house that I'm living in now.
Right on.
Yeah.
Cool. We did that whenever we moved to Oregon from Arizona. The people that bought our house in Arizona wanted to buy most of the furniture too. So when we got up here, we had almost no furniture. And so the first thing we had to do was, go drop thousands of dollars on furniture. And I can't say we made the best decisions, because you're desperate for a couch and a mattress. So you don't really research it or take time to say, do I really like this? You just say, I think I'll like this. And then 3 months later, you're like, I probably should have gone a different direction.
You're an amateur mover. That's what.
Yeah, I mean, I do because I'm insane. I would just buy some of the Amazon futon mattresses, the kind that I take when I go camping, and I would throw those on the floor with some pillows, and that's what we would have until I found a couch that I obsessively researched, and I had a whole decision matrix of couch versus size of the living room versus how I'm going to like this versus different seasons and how I'm going to like it. How much can the cats destroy it? How much can the kids destroy it? There's a lot that goes into these decisions for me. So
she figured it out.
That's not how I do anything ever.
The futon sofa, and I also used to buy a queen size blow-up mattress because that's fairly cheap, and can help you a lot there without even knowing what your situation is going to be if you can't find a quick futon sofa. And then, then you've got as much time as you're willing to sacrifice into living into this terrible situation until you actually find the mattress you're looking for or the furniture you're willing to. I got a lot of flack previously because I used to use my moving boxes as partial furniture until, this box turned sideways is like a shelf. You stack some boxes on top, and then you have a bureau made out of cardboard.
There you go. Although I am willing to fight you on the air mattresses because air mattresses are like $100 now, and my kids break them fairly regularly, so they don't last long enough for us. Which is why I've moved on. Which is why I've moved on to the futon mattress lifestyle, and I'm willing to commit to that. Yeah, for life. That's it. Nothing bad is going to happen to those mattresses ever.
Right on. Yeah. Cool. Well, welcome back. Excited to have you back on the show.
I'm excited to be back. Thank you for letting me back.
Yeah, of course. Anytime. Especially for today's episode, because we're talking about the 2024 Dora report. Because, I mean, by the time this episode releases, I'm sure everyone will have read all 120 pages. And this is going to be a pretty boring episode because you will have digested all the information already. But for the 2 or 3 people who didn't read it, we're here to get you up to speed so that you can converse with everyone else as if you spent just as much time reading it as they did.
So I think instead of people reading it, we're all going to have little AI implants in our brains. And then the report will automatically be wrong because it says AI hasn't had as much of an impact as was expected, except in, drug discovery where it's been insane. But that could happen.
I honestly, while I was reading it, I had this fear our whole episode could have just been feeding the report into Notebook LM and having that running instead of the legitimate adventures in DevOps for our, faithful viewers here.
Mm-hmm. Well, I haven't actually read.
So I did go through almost all of it. There were some pages at the end that I skipped that was just repeating a little bit about what Dora does. And for those that actually don't know, Dora was a separate company that Google bought in 2018 that was focused on the delivery metrics that we all know and now love in and around engineering there's nothing else. I say there's nothing else, although there are a bunch of companies that have started to experiment with a sort of revision of them called Space, which I don't have a lot of experience with, but does handle additional aspects that some of the Dora metrics are missing.
Is Space another acronym for something?
Yeah, because people love acronyms and they don't mean anything, and I'm sure it stands for something, but I think realistically, most organizations can do a better job by just understanding where their metrics are currently at and focusing on improving them, irrelevant of what they are, because no metric is entirely perfect. Because of the companies that I've worked with in my history, often what happens is they say, oh, we have great Dora metrics, or we even have bad Dora metrics, and we need to do better improving them. And then I look at how they're capturing those metrics, and they couldn't be more wrong. Like, you look at them and let's say you're using feature flags and whatnot. And so you're looking at your time to roll out changes in production, but those changes in production have never been tested. They're never being used, and they're behind flags that aren't even that don't make that functionality available to your customers. And so it's like, can you really even say it's in production? And yet these companies are saying, oh yeah, we roll out our code immediately. It's all in prod. It's all being used. And so our values for that are really high. So, I think in those cases that it doesn't matter what the metric is if you're recording it in a way which doesn't encourage good engineering practices.
So I think maybe we should backtrack that a little bit. What is a Dora metric?
Dora is this little girl in a cartoon with a monkey that gets chased by a fox. And evidently she does reporting in between episodes of making cartoons.
That's fair. I'll bet she'd be a better reporter than most.
That was a reference to Dora the Explorer for anyone who didn't get that joke.
I
or
think that may be before my time.
it was,
Gone.
yeah, it was when my kids were young. So it's probably pretty old at this point.
My oldest really went through like a phase where she really loved Dora. She was like 3 or something. It was very cute. It was one of the shows that I actually liked too. Not all of them, but some of them are adorable.
So,
I'm sorry, I totally derailed the topic. What was your question, Jillian?
Yeah, like what is it? We're talking about Dora metrics, and it's like, well, just what is a Dora metric? First of all, I mean, I suppose we can all kind of infer it, right? It's some type of metric that we're using to infer how DevOpsy we really all are. Like, who's got the highest score? Is there a scoreboard that we can enter ourselves into? Like, what are we doing here?
So there was actually like 4 official ones that everyone could be using, and this is where the test really comes, because I don't know if I remember all of them off the top of my head. But there's mean time to resolution when a failure happens, and you need to go and resolve it and get your production state back to working according to your SLAs. Then there's cycle time to deploy changes from the time you start working on them. There's change failure rate, how often failures actually happen because of the changes you're making. And I missed one, and I'm hoping Will knows which one I missed.
Yeah, we have change lead time, deployment frequency.
With deployment frequency,
Yeah.
So that's the last one.
Then
Yeah,
the change
so,
fail rate and deployment recovery time.
Yeah. So
Yeah, so it's interesting. It's 120 pages of text that just boils down to those 4 metrics.
So normally that's what they talk about. And so the question is since they've been doing this, what's new every year that is relevant? Because once you've sort of shared that these are the metrics that every engineering team could be utilizing to decide like how great they are, and they talk about benchmarks and where elite teams are versus maybe behind the curve teams that have a long way to go, what changes from year to year? And so this year they dove a lot more into 3 areas. The first one was they started talking about a new metric, the amount of rework you have. So when you thought something was completed and you have to go back. And this is really interesting because it was always something that made a lot of sense to me and wasn't included. Something else that they don't really talk about is like the number of support tickets you get, like whether or not, like there may not be a production incident in any way, but your customers may be concerned and confused. Your users may not know what's going on, and that's not really included. So they talk about expanding the metrics and maybe breaking them down into different areas that are all independent of each other. And that's sort of what's important, right? Metrics that depend on each other or have high correlation or high cohesion tend not to be as effective because they measure the same thing. Then the report moves on to in-depth review of the impact of AI in our industry and the world, really, but engineering teams and software. And the last part talks a lot about platform engineering and its impact.
Yeah, before we dig into those, I think the thing that stood out to me most in here is the section applying insights from Dora. And it says the recommended approach is to identify the outcome you would like to improve, measure your baseline or current state. And then I feel like this is where so many places start falling down. So the next step is to develop a hypothesis about what might get you to your closer state, and then agree to a plan for improvement, do the work. And then the last one, measure the progress that you've made. I feel like that's where we fail a lot of the times. You know, we like say, hey, we're going to make this better. And then we start working on it and never take a step back to say, did we actually make it better? And if not, let's rip that out. And so over time, we end up dragging all of these failed attempts with us, adding, you know, layers of complexity or bureaucracy or whatever the addition was, and we just keep dragging it along with us, even though it doesn't work for us or improve the situation for us.
Yeah, no, I mean, I think we bring that up a lot in this podcast, and I think the report really dives into it in the executive summary section, which is an experiment is a hypothesis that is time-bound with retrospective at some point. And often, I think we do see a lot of organizations say, oh, we could try this thing, which is great, like you should absolutely experiment. But then there is no review. Like, was it even a good thing for us to do? And that's like there is no, like any experiment is a success, even if it rejects your hypothesis, if you come out with some learning. The only failed experiment is when you start it and never stop. And I think that's what a lot of organizations end up doing. They try something out, they experiment with a different team structure, like even something that we believe is good. I think it was a few years ago that the concept of team topologies came out with different types of teams and how they will work, streamlined teams, platform teams, complex subsystem teams, etc. And it's a great idea to shift an organizational structure to focus on these. But even if it's a thing that everyone agrees on, you should still be like, we believe that a different org structure would make sense for us. And then measure why that is the case at some point later. Like, did it actually have an impact? Because if you don't do that, someone else is just going to say later, oh, that was bad for us. And you're not going to have any data to really back that up. A common argument against that has been the notion of like rapid reteaming or dynamic reteaming. I think there's a book on the topic actually, which is this concept of like you swarm on an idea, you just get it to completion, and you disband the team and create a new team to focus on it. And without really understanding what your core business is or why you're making the change, just arbitrarily making changes to your organization, you don't know if it's going to be successful in the end.
So my favorite way of thinking about applying the scientific method is when it involves people, because the only way that you can actually do that is to spin off parallel universes and to have this whole double-blind scenario where you have all these simulations of different people, and then you have your crystal ball where you're like, well, how did this actually work and how many times? And then you have the different iterations, and then you would have different like branching models of the different iterations too. And since you can't actually do that, you just get to guess. But at least with technology, we could have isolated environments where we really applied the scientific method, but you can't so much with people, because people are chaos.
I mean, you're absolutely right, Jillian. I feel like most companies don't have the sort of scale to be able to do this. And it's a mistake to believe, especially if you're like selling to businesses, that you have the ability to segregate a clear control group and a test and multiple test groups to validate what's going on. I do remember there was a not great book that referenced one of the major tech companies in the world today, and they had talked extensively about horse trading individual countries' populations as far as users go to perform human psychological experiments on the information that the company was providing them to see how humans would deal with that sort of information. And so like at scale, there is something, but that's not like most of the companies. Like it's not my company. I don't think it's Will's company. I'm sure it's not yours, Jillian. Like most people don't work at a company where this is actually a real thing that could be done at a human level scale.
No, I'm also uncomfortable with the idea of like the human experimentation. Like my scenario was a lot more fun because it can. I would just like to point that out there.
So what you're saying is it's okay to experiment with humans as long as they're in parallel universes, just not in this one? Okay.
Yeah, it's fine. I mean, we agreed that's all fine. Like we all like the crossover events in the Arrowverse. Like this is what we do.
Okay, I wouldn't have mentioned the Arrowverse, but yeah, I mean, I obviously was done quite heavily in science fiction and fantasy for sure. I mean, I always like the question like, did you enjoy being an older sibling? Because I only have younger siblings, and I'm like, I honestly don't know how to answer that question. I've never been a younger sibling, so I have.
See, this is what I mean. We can't spin you off. Like we can't create like another experiment with you as a person where then you have the perception of having older siblings. Like it doesn't work. I could spend listen, I have a neuroscience degree. I could spend like a lot of time arguing about this, but we may want to move on to the actual DevOps portion of the show.
I mean, I'm just wondering if there's like you're secretly developing some sort of medical treatment here that like would cause you to forget your memories and still be able to persist in a new hypothetical reality where you could actually experiment with that idea. We've got the news a second time. Point.
Oh, that exists. Yeah. Go smoke some weed. Wake up in a room with a bunch of empty cereal bowls and boxes of Fruity Pebbles going, wait, what?
Did I eat those?
Is memory loss associated with pot smoking?
I've heard that it is. I don't know that for a fact.
I mean, maybe we're missing out on this prime experimental tool that we could be using in legitimate professional applications.
Right.
Absolutely legitimate. I'm sure we could get lots of sign up for that, and it would be fine. No ethical dilemmas there.
Well, what they did in my university is they used to run these experiments all the time, and all they do is they say that,
Well, you have students. The students, like, we don't care about the
students,
ethics
and you
of
pay them.
students.
Yeah, students that you pay like $20 per study, and they will for sure sign up, sign away all of their rights, and do whatever unethical thing you want in your treatment. No question.
Yeah, that's how that goes.
Wow.
This turned out really quick.
It did. I'm glad we don't get real-time analytics of our episodes. I don't know. Maybe this would actually increase our ratings. I don't know. Meanwhile,
I don't know, but the whole like organizational team building and all that stuff, all of those are very interesting to me, because like you can't really test it properly. And being a scientist, the only proper way to test anything is to use the scientific method. So, you know, but then it's like, all right, so you can't test it properly, but what can you do to kind of approximate it? Like, you know, obviously this is not black and white. There are like ways that you can, you know, evaluate the performance of, you know, of team organizations or any of that kind of stuff. And for the purposes of this talk, we should probably, you know, just stick with reality of like, okay, these are the things that people are doing and what are they doing? So was there anything in this report that discusses like, well, this is how your team should be organized if you have a platform team and an AI team and a
so it definitely tries to stay away from. So I think this is one of those things where it's research oriented, not so much prescriptive or evaluating what happened. So the best it comes out with is this is what some people are doing, and this is the data, and here is us trying to maybe explain why the data is what it is. So there is an aspect of a belief that a lot of organizations are creating something that they're calling platform engineering or platform engineering teams. And obviously some of those organizations just took their age-old infra team, didn't change anything or the people or the mindset, and just rebrand, you know, slapped a new label on it and said, oh, this is a platform engineering team. We're golden. So, I mean, obviously those people and what they're executing on and their approach, it didn't change. And so they're likely going to be in the laggard bucket and low performers. And then there's other teams that are other companies that really focused on how do we elevate what we're doing? How do we, and one of the things they really care about is, if we look back at the Dora metrics, is maybe something called developer productivity. And what does that even mean realistically? But maybe it's the number of lines of code that you push out. They don't really talk about this, but it's how people feel. So maybe it's the number of pull requests or the number of Jira tickets that got completed, and no one uses Jira obviously anymore. So maybe they're using like linear tickets that got completed. And we can evaluate number of tickets that got completed equals velocity, thereby productivity. And so did our organizational change that we made cause an increased number of tickets that get completed? And when it comes to platform engineering, the sort of conclusion is that it doesn't have as big of impact as we want it to or believe it should. And even in the best companies, it about averages out to, if you have some sort of platform engineering team and they're doing a great job, it amounts to about 5% productivity increase per engineer. So that's 5% across your organization, basically. And I think this is a really interesting number if you think a lot about it, because it means that if you have 20 engineers, you can hire one person to power your platform engineering team. Because if you hire more than one person, then you're not going to be able to increase the productivity of those engineers any more than that. The 5% times 20 is 100% of the amount of work that could possibly be done. And of course, you don't want to have a team of one person. You probably have a team of 4 people. So realistically, if we just look at the numbers, having a platform engineering team before you have a 100-person organization means that you are spending too much time focusing on whatever the platform engineering team is doing and optimizing for things that the actual, who your users are, the engineers, developers, product engineers, don't get the benefit out of it. You can't increase the productivity further.
Yeah, I would agree with that, because I think in those, like the scenario you were describing, you know, where before you have 100 engineers, I think for most companies, in my experience, like before that, you don't even really know what you're doing as a company. So it's hard to optimize for something when you don't know what that something is.
Yeah, for sure. Jillian, you were going to say something?
Oh, I was just going to say, you were talking about the difference between platform engineering teams, which is kind of a, I would say maybe like a newer phrase, and infrastructure teams. And I was just wondering, what do you kind of see as the difference between the two of those?
I mean, this is where, like, you know, it's
My
weird
opinion,
because,
too.
well, I mean, no, I mean, I think it's a really great question because at least from my engineering experience, and I feel like I'm a little bit unique here because when I started, some of the things I was doing, I would definitely say came into effect because of the mindset of DevOps was now getting out of its seed stages. And the work I was doing was specifically to eliminate teams in the organization that were called platform engineering teams. And now, almost 20 years later, we're now creating platform engineering teams and calling them platform engineers because I think everyone, you know, no one remembered that this term had been used previously. And they're doing similar things, but we've automated a lot of so much to the point of where we feel like the job now could exist again, but doing different things. So when I say infrastructure, what I had meant is maybe writing some scripts to automate the installation of some software on bare metal racks for servers that you got installed. Often they may even be responsible for installing the blades and putting together the server blades in the data center. But for sure, writing the scripts to manage that and maybe send alerts and whatnot. And today, I doubt any platform engineering team is doing that work. I mean, even when they have an on-prem solution and an on-prem data center, they're likely not even building the blades. You're outsourcing data center creation. Even if you have a physical on-prem data center, you're relying on these third-party companies to come in, build it for you, of which then you're likely not even installing the base software, but then you're installing some sort of native system on top of that, either at Kubernetes or CoreOS or something like that.
I think the end product for both of those teams is the same, you know, to create a place for the engineering teams you support to run their applications. I think the big difference between the two is how they accomplish that goal. Whereas an infrastructure engineer will be more hands-on and more tightly interfaced with the infrastructure components themselves, versus a platform engineering team. It abstracts themselves away from those complexities and will rely on like either one or more platform engineering style tools that automate or abstract those tasks away from them. So I think I think the end product is the same. It's the approach of how you build that end product distinguishes the two teams.
Yeah, for sure. I mean, I think my CEO and I were talking about this recently, and she brought up there's like a lot of different other things here that probably aren't necessarily normally associated with it, but things like building golden paths of sets of frameworks and tech stacks that we decide to use, but you know, someone has to do the difficult work of actually configuring it because these things are too unopinionated about what you're utilizing is one of them. Maybe you're utilizing some sort of shared digital or software-driven infrastructure as code, and coming up with those common components that go together would be another one. Sometimes there's an integration with IT systems, so SSO based integration from your IT provider, whatever it is, maybe Google Workspace, et cetera, to power SSO in your organization, and the integration between other apps you have, or the management of the cloud accounts if you're using AWS or another cloud provider. And obviously those things didn't exist 20 years ago.
So I'm not opposed to using like the newest buzzword, mostly because I do that every couple of years on my LinkedIn to get myself a raise. So like that's all fine with me. But I specifically don't like the word platform because it's too general. And then I'm in, you know, these meetings where you have like the scientists, and then you have like the infrastructure people, and then you have like the drug discovery people, and you have all these different groups, and they all use the word platform, and it means something completely different to each group. And then everybody's just having their own conversations, and they don't seem to realize that there's like 4 different conversations going on because we're all using the same word, but it does not mean the same thing.
It's definitely
So that's my rant about
there.
platform, which I suppose doesn't maybe have a whole lot to do with the Dora report, but I don't like
No,
it. It's too general of a word. It's like framework.
I think you're totally on a good point there, actually. So last year I ran a seminar at one of the DevOps Days conferences, trying to define actually what a platform is. And after an hour talking on the subject, the best we were able to come up with is it's something horizontal that supports something else, which is just.
It's the beams. It's the beams in my house. That's it.
Well, isn't that the foundation though? So I mean,
See, I don't know. The analogy broke down. It's like me with cars. I have no idea what I'm talking about.
Well, we got platform. I think the best analogy we had is if you think about the gates for getting on a train, like those are the platforms. You stand on the platform to get to the height of the entrance to the train. So the train, if you had to board it from the ground layer or floor, whatever, from the earth, it's too far away. It's not well designed from that regard. And so the platform lifts you up to be able to utilize that technology as efficiently as possible. And what it doesn't handle is, if you think about that as a platform, it's very difficult to raise up that concrete slab or lower it if the height of the train changes, or if the types of the trains change, or if the train is in a different location, you may have to extend the platform. And so this is, I think Will sort of brought this up. One of the things that's actually highlighted in the report is that platform engineering teams, what they build at first, tackles a lot of the low-hanging fruit. And that's things that are easy, that have a lot of high return on investment, that the engineering teams may be struggling with, right? You see the same problem a bunch of times, and then you develop a solution to help solve that. Maybe it's a script or a bunch of open tofu files that have the same coupled infrastructure together. But since technology is not static, the needs of the team slightly change over time. And so whatever you built is now out of date. It now is actually causing a cost and a burden to the teams to continue to use it, because it's too opinionated, because it's a wrapper on top of what was actually available in the world before. And so actually platform teams in a 1 to 3 year time frame cost, usually, if not well maintained, overall actually hinder engineering teams for being able to deliver stuff effectively. And then until they realize, oh, we're actually getting in the way, we need to build a real product to actually deliver effectively, and then turn that around and extend the platform and improve it over time until it reaches this more effective long-term vision of being more agnostic and being able to just like raise up very small amount, but consistently across for whatever their user group is.
Seems reasonable.
Yeah, seems like a good way to at least reason about it. If we're going to try to set up mental models, and I'm not going to use the word, I almost used the word frameworks, but I'm trying to not anymore.
All right.
Platforms.
I'll take overloaded buzzwords for 1,000, Alex.
So, I mean, this actually came up in one of the communities I'm in. We were trying to define what the difference between code and configuration is. And
that is a very blurry line now.
For sure, right? And so my point was exactly as yours was, Jillian, which is like, it's just a word that helps convey some sort of point that we're trying to make to help get us from where we are to somewhere else. We're just using the vocabulary we have to try to convey our thoughts in the most conducive way we know. And of course, different people understand those things to be different, and apparently also have very strong opinions on what those things actually do mean. And if you try to challenge it, like, does it matter? They do sometimes not too happy about challenging. They associate themselves with who they are based off of the tools they're using. And if you said, oh, you're just a configurator, that may drive a stake in some people's personal perspective of themselves.
Yeah, for sure. That could go very deeply into a whole nother topic, but a lot of people in our industry, they do tie their professional identity to the tools. Like, oh, I'm a Terraform person, or I'm an Ansible person, or I use AWS. And it's one of the things I try to share with people whenever I talk to them about their careers is, don't tie yourself to that technology, tie yourself to the problems that you're solving, because in the course of your career, those technologies are going to change, but the problems you solve will be the same. And it's a very subtle but effective trick to making sure that you stay relevant for additional career options over the years.
That's why my title is not BioPearl software developer anymore. It is, I don't know what it is right now, but it's something. It's something on LinkedIn. It's not BioPearl. It's not Catalyst. I don't know. I don't even remember what any of the old bioinformatics frameworks now, but they were all Perl based.
Nice. How could you let that go?
I don't know. Yeah, I would think most people would kind of, I guess if you're talking to like newer professionals, I could see how that could be a problem. I don't know. I don't think people in the field for a long time would associate themselves with the particular tool, but I could be wrong about that.
That Perl is one of those, like the old school
The Perl people hung on to
people.
those for like a long time. Okay?
Oh yeah, and they'll
time.
still argue with you today about how great it is and how humanity is doomed because we've moved on to something else.
That was the first programming class I actually ever took. I had no idea what they were talking about, and the professor just launched into this whole Perl versus Python thing, and I was like, I just want to program some robots. Like, I don't even know what you're talking about. But it stuck with me, 20-something years later. Here we are.
So Warren, you were going to chime in on Perl.
Oh, well, there is a joke
Much
there.
to
There's
say.
like some OCR that converts artwork into text. And it was like a terrible OCR program. Like it did not do a very good job at all. But if you threw an image at it of some famous artwork and it would generate just arbitrary text, which was like periods and semicolons and dashes and @ signs. And literally everything it generated was a valid Perl program.
It's great. It's gobbledygook, but Perl will take it.
Perl is the honey badger of programming languages.
I still check in on like the Perl 6 news sometimes, and I'm like, such hope and such despair in like one small space on the internet. It's fascinating.
We'll get that when we get Half-Life 3.
Mm-hmm.
So let's talk about artificial intelligence and how that factored into the Dora metrics this year. Because
So excited for this part. I get to disagree with the whole thing. The whole like
All
one
right.
page that I read.
Well, never let lack of knowledge be a reason that you can't argue a point.
That's right. Lack of knowledge should never inform my opinions.
So in looking at it, this is a hard graph to read.
I found the graphs to be challenging. So anyone who's actually looking at the report, what you have to remember is that at the bottom axis, it's often like 0.1, 0.2, 0.3. And what it really means is percentage of the total population or the actual percentage increase overall comparing the options. So really, it's just often 10 to 20% for the different areas. There's the elites are, somewhere around 10%, and the lowest minority is also 10%, and is about 20 to 30 for the mid pieces. I don't know if that's the graph you're looking at, Will, but I found personally the UX on the graphs not to be the best.
Yeah, that's very confusing. So I'm going to go with the text up above saying that 81% reported they're shifting their priorities to increase incorporating AI into their applications. What's not clear is, well, I guess given the scope of the audience, we can assume that 81% of DevOps professionals are incorporating AI into their DevOps services.
I think it's actually businesses is the total population that they're talking about here.
Okay.
So like 81% of businesses are trying to incorporate AI into the final product that they're utilizing. I think there's also a different metric for the amount that are trying to utilize it as a tool to do some sort of software development, but I'm not sure that's totally highlighted there. I don't know which one the 81% was. I'm so totally curious what the thing was that Jillian found that also vehemently disagreed with. I'm just waiting in suspense here.
So now of course, I'm looking at the report and I can't find the sentence, but I thought that it was something like, AI adoption was kind of less than predicted, or AI significance was less than predicted. And I found that to be completely opposite, especially in drug discovery companies where everybody was like, yeah, whatever, like we've seen these before, right? Like Microsoft came out with their AI that was for healthcare a few years ago that was supposed to revolutionize everything, and it revolutionized like nothing pretty much, and so on and so forth. And that has absolutely not been the case with these with the newer models, with the Chat GPT, the Claude ones. I haven't gotten to try out the new reasoning ones yet. But in particular, the AI seems to have this kind of scary good knowledge of how chemistry works. And it's great because my brain is like equally divided in half on this opinion, where it's like, well, the AI sort of understands language and human language, and that's what it's trained on. And our representation of chemistry is also humans creating language to represent something. So this also makes sense, but it shouldn't make sense the way that it does. And like the results that you get, everybody, just looks at and says, this should not work. This is so, this is so scary good what the AI can do, where you give it like a string representation of these compounds or these drugs or whatever, and you can take it and you can like start asking the AI to generate you new drugs. Like you can say like, hey, here's, I ran this experiment and here's all of these compounds that docked against this other compound, make me 50 new ones that are going to do like, that are going to be comparative or something like that. And then you can also, with these bigger context windows, you can throw like all kinds of public data sets at it. You can take open targets, you can take the therapeutic data. Like there's just a crazy amount of data that you can incorporate into it. And it seems to be doing really, really well. And so that's my very narrow view of AI. That is the only thing that I actually care about, which has nothing to do with this report. But I found the adoption to be much greater than was expected across the board. Like I had somebody say like, oh, it was just this toy that I was playing with a couple days ago, and now it's my whole job. So I find this very interesting.
I think that what is
also the AI is going to be making our medications, and I don't know how I feel about that.
Oh, it's coming.
It's coming.
I mean, there is, like I've always had this perspective of humans make mistakes, and I think we forget that. And we assume that if we design an AI process to handle something, that it has to be perfect. And realistically, it just has to be equal or better than what humans are doing, or even worse if there are some other trade-offs. And often when we evaluate a process, there's a very common aspect for engineers who say, oh, we're looking at the code or the output, and it's not actually 100% correct, so we should reject it. And I don't think that's necessarily the right mentality to have here. But what you're messaging, what you're talking about, Jillian, I totally agree with. I think outside of the software engineering space, the usage in product that are being built or the end product can be hugely valuable almost everywhere. I think as far as the report is concerned, we should look at the impact of the product the company is creating versus the adoption by the software engineering teams. And so I think overall what we are seeing and what the report says is that everyone's optimistic, or most people are optimistic about the usage of AI for doing the development, doing software development, using it in the teams. But when it comes to the actual product delivery, success, performance, durability, reliability, that actually decreases with the usage of AI. And I think this actually makes a lot of sense, where we're employing very knowledgeable, inexperienced engineers, a lot of them, to build us our products. And so of course we can do it faster, but the outcome of what we get is going to be worse. And it's going to be the case for, I think, a very long time, unless we overcome the barrier of making truly more intelligent LLMs. And the nature of LLMs, I think, is incredibly limited there in that regard.
I think the LLMs a little bit, they're going to have the same problem specifically for writing code that the package managers do. Because when I've tried AIs out for writing code, it mostly works, but it'll mix in different syntax versions of different different programs. So like if you're using like pandas, for example, that's kind of a common data science library, and they like to change their syntax quite a bit. So you'll get like different changes from different versions and things like that. So I think that'll be kind of the next, I see that as sort of the next big change that'll have to come along for the coding AIs to really take off.
Yeah, I mean, what I've seen is sort of two-shotting the output, where you keep a collective doc of some of the learnings that you want to have passed into every code generation you do. So like, if you know there are differences in pandas, what you should do is have a doc that says, and you can use your package manager as the source, like, only give me output that matches recommendations based off of the versions that I have, or specifically say pandas, whatever the version 1.35, and then it will help to make sure that it generates output that matches the syntax from that version. And if you don't give that, then of course it's going to pull out the most relevant thing based off of the problem that you've asked, which may not be in the version that you're utilizing.
Well, I think that's going to be interesting with the newer models having such large context windows, is that I want for PyCharm to reach the point where I set up my interpreter and then the AI is just like, this is the interpreter. These are all the versions and things that we should be using. Just stick with this, the same way that if you have like the code complete or anything like that set up, it takes from the doc strings and stuff of the functions of the libraries that you're using. So I kind of want for it to do that.
I think that that's one of the hidden benefits of using AI specifically for things like writing code, is you'll give your chatbot or whatever you're using a prompt, and then it comes back with an answer, and you find scenarios like that, and you're like, oh, okay, that's 100% my fault because I didn't tell you all of the constraints. And for me personally, I've found that it's helping me to become a better communicator, because I would have the same problems interfacing with humans. I would say, hey, go do this task, and they come back, and I'm like, well, okay, I forgot to tell you it has to run on Linux, or I need 64 gig of memory, all these little details that I should have communicated up front. And so the same mistakes apply. It's just more rapid feedback for me to understand that I wasn't clear in my request.
Yeah, it's my fault. I should have mentioned that we were using a 64-bit operating system here instead of a 32-bit. I mean, that's a new invention, I know, like just last year. So I can understand how an LLM, got confused here. But yeah, for sure, that is exactly what's happening.
And that was some of the, looking at the task reliance on AI here, 74.9% of the people responding are using it for code writing. 62% for code explanation. I use it a lot for that.
What do you mean? Do you highlight your code and then say, write me a doc string, or what do you do?
No, I'll copy some code into it and say, what is this thing doing? And then it comes back and tells me, especially in whenever, it's a language I don't work with very frequently. If I'm helping someone debug a Rust application or whatever, I'll drop that in there and say, what does this thing do? And it breaks it down.
See, if you get in that situation, I almost recommend taking the next two steps, which are first then, ask it to generate unit tests for it if they don't exist, where the unit tests are the documentation for the code, and then tell it to rewrite the code so that it's simpler and more understandable. And since you have the unit test as well, so that the next person that looks at the code knows that what it does.
Oh, wow.
And also you have the unit tests that were generated and validated regressions for the previous version, so the new version doesn't break either. And yeah, it's extra steps, but it reduces the loop there.
Damn, level up, Warren.
I got some good ones here. So I think the doc where you actually have a bunch of recommendations in that you keep including as context over and over again is one of them. Another one is that we're going to very quickly run into this place where LLMs are trying to generate code in languages that is not optimized for. Like the software languages we've created were all created by humans to do human-related understanding things. And over time, if we lean more on LLMs, we're gonna get to the point where we actually want an LLM-focused language where it will be able to better understand how to generate code that does the correct thing, understand the context of what code has been written and documentation around it in order to do the right thing. Which means we're going to end up creating software languages which are less understandable for humans and more understandable for machines, until we get to a point where what we're writing is almost completely not understandable by us at all. But I think that's still a little ways out. But we're going to get new software languages for sure that better incorporate this concept.
Yeah, and I think that's the big, that's the basis of every sci-fi AI takes over the world story ever, right? Is the AI starts improving things till it's beyond the point of us being able to understand what it's doing.
Yeah, but I mean, look at there's very few of us. I did do this in my academic career, but you go look at the bytecode that was generated or the assembly by the assembler. And you're not looking at that and be like, oh yeah, I know. Like it says shift like 3 registers here. That's clearly a crypto, hashing algorithm, obviously, with a bunch of jumps. And this is making an HTTP call. You see the register here and the request and the socket maps. Yeah, of course. Like I know exactly what that's doing.
Right, parsing the binary in your head.
Yeah. Or you're looking at the minified JavaScript CSS for websites, and you're like, oh yeah, I know exactly which file this came from and what the stack trace was. When this is gonna, no, it's just like random letters that make no sense, with parentheses and periods between them. So I mean, we're already at that stage. I think there's just another one above here, which is between using LLMs as the input. They're still not the input to software development. But it is gonna change. We're gonna change the languages that we're utilizing so that they match better with our non-organic coding partners.
I remember like years ago when the browser wars were like at their peak. I was with a group of people and we were talking about, different browsers, and everybody was vouching for their favorite, and one of the guys in the group, he says, a real man just uses curl and parses the HTML in his head.
That is a fun one. But see, that's why I'm a little bit surprised that I don't the LLMs don't do better with code, because it is still humans creating models out of language. Right. I mean, the code isn't completely that, but it can, it's close enough. It's as close as chemistry is anyway. So why do we get these really good results in some of these fields that have these representations of data that at least in part use something that kind of looks like a language, and not so much with the code?
So someone's going to call me out on this because I am for sure not the expert. So there's that caveat, and I'm sure that's
nobody is the expert. That's the thing. Nobody knows. Every meeting I'm in, we're all like, "Why is it doing this?" We're like, "I don't know. What are we doing?"
That part doesn't get. Yeah, I mean, if it gets cut out of the podcast, someone will definitely call me out. Handling human speech in written words has a very single directionality to it. Forward directionality as far as linear goes. In time, you sort of read the context, you get the result. Whereas software development has a need for the output to be sort of understood from a huge context of a single class in object-oriented or multiple functions, etc. And so there's at least a bidirectionality, things going forward and back. Like by the end of function or a file of which you have some source code, there's maybe some braces at the end, etc., which aren't just based on the previous lines. They do impact what should have been written almost. And same across files, whereas you could have a many-page book where each page in the book only followed from the previous one, but it's software development is more of like a choose your own adventure. Some of those functions are used outside of the context of that file. And so there's a lot that goes into it that isn't just the same as natural language. And so there's actually different models that are being used in order, built up and designed, and how we're actually orchestrating the consumption of that data and the neural net that we're creating to process that data is fundamentally different depending on the output. It's much closer to, say, creating an image than it is human language, like written text.
That's interesting. Yeah, you're right. I'll bet the probability space is much greater with code than it is with human language, right? If you look at how the AI kind of takes things, it's part of a very simplified explanation is that, it sort of creates the probability that the next character in the sentence will be this thing. And it does that sometimes. And with natural language, with people speaking, I mean, I don't know, but I don't know that this has ever been documented anywhere, but I would guess that it's much, much smaller for natural language than it is for code.
You can
code is at best to make your own adventure. Pretty chaotic.
No, yeah, for sure. You can understand a lot more with mistakes, I'll call them, in human natural language, things that don't make sense, sentences that run on or curtail or miss the predicate, whereas with code, it's going to get executed. And so there is some fundamental difference here. I don't know how it is in chemistry. I always can't speak to that. It's possible that the models are highly both fine-tuned with that in regard, or maybe it is just the obvious result of a bunch of natural language as well. It lends itself well to that. But I could imagine experiment diagrams or state diagram transfers. I forget what they're called in chemistry. To convert from a couple different molecules to different other kind of molecules, like that in a course of, say, a chemistry book could be challenging to get right. Like, it could definitely swap from talking about one kind of molecule to a different one later, and where in natural language that may not totally matter within the context of running experiment or actually designing a product that someone could use would not make sense at all.
That is always a little bit freaky about the AI doing things, especially with like medicine and drug discovery, where you're like, listen, one compound is safe for you to take. The mirror image of that compound is going to kill you. Like, and these are, they're the same thing. They're just mirror images of each other. And we got to make sure that the AI gets this sometimes. I know the ones that I've experimented with have just been the general AI models. I know like new ones are coming out all the time, right? And I'm sure there are going to be ones that are more targeted, specifically to certain fields like drug discovery or astronomy or, whatever the things are.
I have to know now, does it often mistake getting the L-chiral and R-chiral molecules mixed up? Or is it like, does it know that it should mostly be L-chiral?
I don't know, because I haven't been running those types of experiments. That was just kind of the easiest thing that I could pop up with in my head to say, these are the stakes for the AI getting things wrong. And they can be very simple switches, right? Like this has happened in human labs where there was like a type of medication given to women during pregnancy for nausea that caused a bunch of birth defects. And it was just a chiral compound. So your chances were, like almost 50-50 if you'd taken it, things like that. So I don't know. Sorry, I lost my train of thought there. I don't know what I was going on about.
I mean, this was always so riveting for me that the molecular compound equations could result in L-chiral and R-chiral compounds. And in the human world, at least, like 99% of things that we encounter are all L-chiral. They're all mostly harmless to us. And things like the R-chiral versions of them, which almost don't exist in nature, are all like incredibly poisonous for us to consume in any regard, causing instant death. And I don't know, that was just always so interesting to me.
Chemistry is pretty wild. I like chemistry too.
I'm trying to think if there's anything left in the report that we haven't talked about.
There's one thing I want to bring up because I found this to be really interesting. The drivers of adoption for AI. Number one, marketing. Number two, forego bureaucracy. Number three, what if our competitor implements AI before us? And I find those interesting because I think those are all the exact wrong reasons to implement AI. Like, none of those say, oh, because it's going to help us deliver a better product to our customers, which I think should be like the primary goal. Well, to do that at a profitable margin. And
I think that's kind of the end result, and people tend to, drill down more and get more into the particulars of what they're doing on their day-to-day. But I think, yeah, like at the...
But you can do all three of those things and not make a better product for your customer. The way that they're stated here, anyways.
Could be. It could just be screwing around with AI, and it could, not mean anything.
I think there's right now, I think what's happening is it's always a challenge for you when you're marketing your product to explain concisely what the value is that you're offering so that you capture your customers to come and utilize your thing. And because it's such a challenge, I think a lot of people are jumping to just saying that AI is included in it because it is being used as a proxy for all the things in which AI could hypothetically be doing to make it better. But then there is this sort of death spiral where that encourages the use of AI in the product to do those things, even though you don't fully understand the value it's offering. And then you have to say that it's using AI to do that thing because people are concerned that if you're using AI, the output may not actually be what it should be. It could be making more mistakes than you would expect if it was well coded and validated. And so you end up with this death cycle. And I think that is certainly part of the problem for sure.
Yeah, I think especially on these experiments where they're large enough scale that you're not going to want to replicate them with people. So I see a lot of literature mining projects where it's like, we want to know all the literature that's available on, whatever, this new cancer. Okay, cancer. And I mean, I wonder how much it would cost if I was going to be like, I'm going to download 3,000 articles, ingest them. Well, I know how much it costs for the AI to do it, but ingest them with the AI. I'm going to ask it a bunch of questions and get some results. How much would the same experiment cost to be doing with people? I don't know, but I'm going to guess, I don't know, how many papers can you really read before your brain turns to mush? I'm going to put it at about 10. So you need a good number of people to do that, and then I don't know of anybody who's doing that kind of experiment. So I don't know. That's always like the interesting thing for me with like the marketing and the more like wiki style experiments is that you can't really have a control group there. Not one that I'm paying for anyways. Not going to do that.
I mean, I think it would be interesting if you're talking about trying to come up with like real conclusions based off of having downloaded or consumed all of those articles. Because if we look at what a human would do, like let's say intelligent software engineer, one of our viewers, right, probably write some sort of script to go and curl all of the documents, get them downloaded, and do some sort of regex matching to find words in the document that you care about. And then utilize that and investigate each one of those more specifically, right? You start like a very high level approach to filter out the information you don't care about into only the parts you do. And I think that could help a lot. Now, if we're actually talking about consuming all of them and coming up with a collective, unified epiphany on the topic, I'm not sure that the AI would be able to do much better job than basically regurgitate some parts of the individual documents itself. I don't think it's going to be able to pull from a second corpus of like sets of epiphanies you can have and like do a match, right? I read these documents and then like, there's 6 possible conclusions you can come to and, pick one of those. I think this is where humans are still generating new ideas, whereas we've limited the LLMs on what they will actually generate. If they generate stuff from not the documents, we call it wrong, and usually it is. And if they're generating stuff just from the documents, then I think it's losing some sort of insight that we would get even if you took the human fried brain approach.
I think that's very true. The LLM is not going to innovate the way that humans are. Like, presumably you could get some very smart human who looks at all those papers and says, this is what they all missed. And then we'd have, some crazy new scientific thriller novel that a bunch of nerds reading papers or something. I don't know.
All right. It feels like it's time to do some picks.
Okay.
All right. Jillian, welcome back to the show. What's your first pick?
I don't know. So the show got me thinking about neuroscience again. So I'm going to pick the book, The Man Who Mistook His Wife for a Hat by Oliver something. But the title's pretty distinctive, so you can look it up. It's on Amazon, I promise. But it's really interesting because a lot of the experiments in neuroscience that are done, you can't just run around doing those to people. Okay, we have like ethical committees for stuff like that. So instead, what happens is that people who have suffered certain brain injuries or had strokes or some like something like that has happened, they are very extensively studied, and then we say, oh, this. These parts of this person's brain got knocked out, and then this is what happened. So then you get very interesting cases, like somebody saying, this is my wife over here is actually a hat, and you have all kinds of crazy stuff that goes on when you start messing with the human brain. So that's that, and then you can learn all about why you should not be experimenting on people.
Seems like a worthy lesson to learn.
Very good. It's important.
Yeah,
why you mess with the human brain.
There may be some data points if we open up a couple of history books that provide additional context there of why that's a bad idea.
There definitely are.
Really?
Maybe, I don't know. Just throwing stuff out here. What about you, Warren? What do you got?
Yeah, so I didn't pick a book this week. My pick is going to be QCon San Francisco, which should be happening this week. My CEO of Authoress is actually giving the only security talk, I believe, at the whole conference, which is titled "Security or Convenience? Why not both?" And so, if you're there and you have the opportunity to go and see it, I highly recommend it. There's a lot of interesting insights where innovative companies are focusing some of their opportunities and what is almost now considered legacy.
Right on. Nice. Cool. For me, I'm going to pick a book that we were talking about just before we recorded this episode, and I think it's with the conversation we had about AI. I think it ties into that, and we'll have some relevance there. It's a book called "Trust Me, I'm Lying" by Ryan Holiday. You may know him from the Daily Stoic, but prior to that venture, he was a marketing professional and did a bunch of different things in the marketing world that he's not proud of. And this book is his admission to doing those things. But it's really interesting to read, to understand how corporate marketing works and the things that they're willing to do and will do to promote their brand. So yeah, Trust Me, I'm Lying by Ryan Holiday. Super interesting read. It will forever change every commercial, website ad, and blog post that you ever read. And do you guys hear that clicking in the background, or is it just me?
I do.
Oh, good. Okay.
I think that's my computer.
Right on.
I
Yeah,
don't hear it.
that's good.
Yeah. Well, sometimes it's just in my head, and then I ask, and everybody stares at me awkward, going, no, dude, you just go over there in the corner and do your thing. And I'm like, okay. All right. Well, with that, we have an episode. Thank you, Warren. Thank you, Jillian. And to all the listeners out there, thank you for hanging out, listening to our rants and ramblings and misdirection. Hope you enjoyed the show. If you did, or if you didn't, you know how to find us on various social media platforms. So give us a shout and let us know. We'll see you in the next episode.